I have a. Okay, let me see something. You have 0 xy's. So that's why. You see, you have 0 xy coordinates. This is delete. Just I want to see few things. So after that, we will go back to your selected bin. Okay, so this is what you have it. Now, okay, your location map has to be here. Now you want to convert this into
Okay,
depth
depth
conversion.
conversion. Okay, very
So
nice.
here you have input data. Input data will be
Yes, the
okay.
trouble
It
is
is on the
here.
other screen.
The trouble is here, yeah.
So now you have connected this, right? You require the velocity model for this. Where is the velocity model?
I don't have for this velocity model.
Yeah, otherwise you cannot convert the time to depth. How you can convert?
Yeah, but you can estimate with the Evo. I will see inversion.
I'm sorry?
You can do first to do Evo analysis and make the inversion.
Okay. AVO, for AVO analysis, you should have the gathers also, right?
Yeah.
Not the stack. Yeah. So offset variation, amplitude variation with offset. So you should have the gathers. So from the gathers, you can do the inversion, but not with the stack.
Okay.
So for a depth conversion, what you have to do is you need to have velocities for this particular area. Then only you can able to convert the data.
Okay, we can insert like parameters.
The parameters, like it is always how you see the step size. So this will 2000 samples with a step size of 5 will give you 10 kilometers. Okay. So if you put say your step size, your depth interval is every 10 meters, then it will give you 20 kilometers. So what is your area of so now this will give you 10 kilometers.
Okay. Try in this way.
I'm sorry?
Try in this way.
No, it should be, you see, your input data has to be post stack. So this is not stack. And we require the velocity model also. Is it a stack?
No.
It's not a stack. Okay. So for this, we need to have the data is in a stack. It should have a CMPs.
Okay, we can try to change the input data.
We don't require it because since we have already added this, so we should able to. Oh, don't have any data. Okay, we have something. Okay. Okay, this is you have some data. Okay.
Yeah.
What do you want to do with this?
Yes, this is a sub-button data.
Okay. And okay, I can see this is a single line, correct?
Yeah, it's in line data.
Okay, I can. It's a single line data.
Yeah.
And then you want to filter this data?
Yeah.
Okay, so for example, if you want to filter this data, as I can said yesterday, and pass filter. Okay. I don't know what is the frequency ranges of this data. Let me see.
So, yeah.
What you basically want to keep, what frequency you want to filter out?
Between two high pass, you can set 13, and low pass, you can set 10.
I'm sorry, can you repeat?
High pass, you can set this value.
So, can you type in what are the parameters you want to put in? You can type in.
No.
This will be low frequencies.
No,
You see this one frequency, this one, and what was the so 5 and 200 will be your actual frequencies. The 1 and 210 are basically your tappers. So, in which frequency you want to see, so you can keep that numbers here. Can you type?
Yeah, but for filter this, I mean that this range.
Yeah, because this is your frequency range.
Yeah.
But I want it, which frequency range you want to filter.
I want to
say, for
extract-
example, let me show you.
Yeah.
Can you give me a control? Okay, let me see. Okay, so here you have 100, 125. So if I do this, okay, and then I will go there in the input gather, I will connect this to this, okay. And then with these parameters, these subgroups, all groups in a new bin. You see, now you can see the data, correct?
Yeah, it's correct, yeah.
But I want, it is up to you which frequency you want to keep the data, which frequency you want to. This is before and this is after.
You can add also gain.
So you can also increase the gain, absolutely. You see here, I will, if there is any bad values, it automatically fixes. If you want to create a difference, it will show you the difference, like you are not missing any of the, input data. You see, you are taking out all the frequencies, lower frequencies, correct?
Yeah.
So now you can see this is before and after, okay?
Okay.
So you can play with these parameters like however you want. Say, I would say 150 to 250, okay? Something like that. Still you can clean the data, but I don't know what is your objective of the process.
Yeah, for example, remove this noise, because I think this is a noise. This is a column of water. Yeah.
Okay, so we can, I don't have a control, now I have a control. So with this, we have removed the, because I'm not familiar with this kind of a data, because mine is exploration seismic. I know which data to keep and which one to throw it, okay? So now you have this data. Now, if you want to
you can pick the frequencies on the image.
yeah, you can see, for example, if I click on this,
pick the frequencies on the image.
Yeah, you see, this is a frequency range of this particular area.
Yeah.
Okay. If I want to select this particular area, it will show me this particular area's frequency. See here in the dB. So this is the frequency of only this particular area, whatever the selected area.
Okay.
But if you want to see the entire area, okay,
not. I want me to be the inversion. I want to select this area, okay, and purge all that are in this area.
Filtering. Yeah, whatever. You see, you don't want this frequency because you have this frequency, right? What you are having is you have a any frequencies below. Say, for example, you want a frequency 1000 to 150. Then you may not see those. You have to manually put in. It's not like the system will automatically do it. Okay. And now you check your input data. Probably, you see, if I increase my frequency, now I remove in some of the input, right? So you have to play with the parameters, which frequencies you require it. Then based on that, you have to test your data. See, still, so whatever the frequencies we have put it previously. Excuse me.
No, you may.
So now you see.
No, you don't understand me. I want to remove all of this. So this is
what do you want to remove all of that? What do you mean by that?
All this part. So it's
Which
just
part?
it's just
I don't see
it's just the way
I don't see your.
It's just the way that I say pick the frequency here. Because if you select in this area and I pick these frequencies, I purge all of this part.
Okay, you anything above that you want to remove it, right? So if that is the case, you need to pick horizon then. Horizon picking. You have to do this. You have to pick a horizon. This will be your output gather. Okay. I don't have any of your data because it doesn't have any of the horizons, because it's not a stack. It's not a stack. Okay, now you have it. If you want to pick I need to play this with the parameters, but I just want to test it.
Okay.
So if I understood correct, you want to.
You can not auto pick.
You can.
You can.
But you have to play. You have to spend some time on it, and then because you have to play with the parameters. Okay. Yeah. You see, let me see. What we are looking at is the nearest or the nearest. Okay. Automatic picking window. Okay. 300. Picking threshold. Start time function. 300. Let me see if it improves. You see?
Okay.
So
Yes,
this.
Yes, the final result is the same, but probably I asked you if it's possible to filter all this part, selecting these frequencies. Yeah, I think it's the same, but is automated.
If you want to pick anything above this, right? You don't want any frequencies above this, right?
Yeah.
What we have to do is you have to pick a horizon and then you have to apply a mute.
Okay.
Mute. You see here, mute by C bottom. You see here, mute by C bottom, wherein you have to put your input data. Say, for example, I don't know, because your requirement is different than what I have it. Do you have any water depths on your trace headers?
No, it's an interpretation. I don't have also multi-beam data to establish the water column.
So unfortunately,
multi-beam data or side scan sound. Yeah.
Okay, so it's really.
Yeah, but I think it's too easy to understand that water depth is that. Yeah.
No, it's not what I. But for us, we understand this. But for the system to identify to mute it, we need to have that information in the trace headers.
Yeah.
Either you're not, you have to have that information, then you can. Otherwise it's really tough, right? So this is what I was trying to say, because you should have that, and then you can use C by water bottom, mute by water bottom. This is another option. There are many options, but how you have to use it is up to. You see the C bottom, what the parameters which I have used it. You see, this one is I have used a constant water depth of 300. Okay, so if I use 200, this will move. You see, this is what I. But we should have the water bottom times, then only we can able to do it. Otherwise,
but I think there is a not constant surface. It seems not to be a constant surface. Is the
that's the. Yeah, that is what, because it is a constant. I'm just showing it to you, Mr. Matthew, because I need that water depth information, okay, so that I can use that information to mute exactly what portion we require it. If you don't have those trace headers, it is very unlikely to mute anything above this part. Okay. So like, for example, this one, if I use it as 3200, and then whatever the water velocity it is there, that anything above that, it will mute it. But we require, we both know that this is not the constant water depth, because the water depth is keep changing, isn't it? So that is the reason why I have told you, you have to pick a horizon. Then based on the horizon, you have to pick the horizon and then mute. Based on
the part. Okay, so.
Okay, mute. You can use mute by velocity range. No, we cannot, because you have a. This is not a short data. Mute. Okay. Let's try. Do you know the velocity?
Mm-hmm.
The velocity. But it doesn't work because yours is not an offset dependent, right? Because you don't have any offsets.
Yeah. You can assume offset about 2 meters.
Yeah, yeah, it doesn't work. Sure, it does. Yeah, you see, is we don't have anything because our lower limit and the upper limit is basically mute line. This is muting everything within that.
Is the question I just see it the first.
Yeah. So this one we need the headers, then we can able to do for anything, because other than that, I'm afraid I cannot help you with that. Because even you don't have a, this is an LMO function, cannot use LMO because you don't have any.
You want to apply a LMO function? Yeah.
Yeah, this is not a short data, so whatever the tools I have it requires in the offset information and all those. But then that.
Yeah, you can do the, here you can try the depth conversion.
Okay, for depth conversion, okay, let me. Okay, I will put this. We still require the. Yeah, it is should be a post stack. Requires a post stack, because if you look at this, the data is you have 4,729 short gathers, correct?
Yeah.
So you have these are all individual shots, but this, to convert the depth conversion, we require first this needs to be.
Okay, you need the vertical logs, SVP. With SVP you can do this, but not in G platform, in GSpace.
I'm sorry?
We need the vertical logs, SVP.
No, I'm not familiar with the GSpace, to be honest. But what I was trying to say is why that information it is showing you that it is a post stack. I can show you. I will show you something. Okay, very quick. Okay, I will show you very quickly, so you will understand why. What is the post stack or something, okay? With your permission,
Yeah.
I will use the ground files,
Yeah.
geomarch, platform. Oops, nothing is there.
I don't know.
You didn't install the demo data? Okay,
Yeah.
it is there. Yeah, it is taking bit time. Okay, I will quickly show you what I was trying to say. Okay, so you will understand that the error, why it is giving the error. Okay, load geometry from SPS, because this is
Because
the
this
seismic.
is data acquired with post-TechEd.
Okay, so here I have to, it's taking some time. Okay, so this is SPS.
Okay, we need the SPS or the VPS. Yeah, we can do the conversion journey because how you do in the Word to understand the depth of layer in sub-bottom data.
So this is your navigation. Okay, this is your seismic, and this is your navigation. So it is telling you where the shots are located. Okay, then what we do, we apply the geometry. Okay, to the seismic and the navigation. So we are telling that, okay, you read the seismic, the navigation from this file, okay, and seismic from this file. This is a seismic and the trace headers. I was talking about the trace headers. So once you have this, let me quickly show you. Okay, it will be okay. So what it gives me is this. You see, these are my elevations, okay, or the depths, okay.
Yeah.
So for each source and receiver, I should have these elevations. So now my data is in this format, okay, in the exploration seismic. This is a one shot, whereas in your case, the shot
yes,
is
this is
like
the trace for one shot. You filter the
one shot.
Yeah.
Okay, and now what I have to do is binning. I will show you this one also. So if you look at the read segue traces information, you see I have 251 shots, correct? I have a number of receivers is 1 and the number of bins is also, CMPs are also 1, correct? Similarly, your data is also the same. You see, total number of sources is 1, your receivers is 1, your CMPs are 1, correct?
Yeah.
I need to do the binning, okay? I need to do the binning, okay? Then only it will become, okay? Let me show you. So this one will be 12.5, 2.5, whatever the values. Okay. So this one will create the CMP, okay? Now I can see that there is a fold, okay? I have a shot, I have a fold of 70. And now in the location map, now I can see where my CMPs are. Okay, these blue lines are my CMP. This is my line. Okay. Now I can save this into an internal format. Okay. This is the input. In the trace headers, I need to take it from the binning. Now, if you look at this, your total sources remain the same, but your receivers are 782 and your bins are 1282, correct? But previously you have only this much, correct?
Correct.
Okay, So this is what the binning what it will create is. I will just save this. Later you can delete this. Okay. Just get this. Okay. So I'll be creating this. Okay. Now I save this. Now next what I need to do is to convert that your data into depth. This is what the whole exercise I want to show it to you. Okay. This is what I read it, and I'll do a stack imaging. Okay.
Yeah.
This one.
So, but you can make the stack image also for the first the sub button. Why you can do the stack image?
But your data doesn't have any bins, correct? Your data doesn't have any bins, right? So here I can create a stack imaging and I can show you. Now what it is currently there is a velocity. This is what I'm picking a velocity. Okay.
Yeah. It's like math. Yeah, you like one the analysis.
This is a right. I'm picking a velocity, correct? At a different locations, right? So something like I pick the velocities. Now when I execute it, so I have a stack. You see? Okay, let me add AGC here also, so I can able to see that. Okay, now I can able to see something. Okay. Now this is the post stack. Okay. Now when I see depth conversion, okay. Here my input will be from the stack imaging, my stack inline. Okay. And my VRMS, even if I won't provide that VRMS, let it be. Okay. So I will, at least now it is giving me a different error message. Yes or no? Because
you need answer file for the velocity model. It's the same that I ask you.
Yes. So here when I provide the VRMS, okay, then it will convert. Now it is converted from time to depth. Now you can able to see that. Now this is the time domain. This is the depth domain, and this is the time domain. You see? It will change it, but we require the required information. Otherwise, you will end up with error messages. Now it is, you see, this is a depth in meters, and this is in time in milliseconds.
Yeah.
So this is what I was trying to say to you, because your input data is not stacked. If I try to stack your data, for example, as you said, right?
If we can try, for example, to stack the data. Try to restack, I think it's possible to restack the data.
No, input data handle is not valid. You see, it is directly giving me an error.
You can resample the data. Why you can?
No, it's not about resampling it. It is not about the resampling it, because a stack imaging requires binning your CMP positions, but your input data doesn't have CMP positions. You have a one CMP.
And you can have some techniques, algorithmics like resample to do this artificial, because I know that all the seismic traces acquired, for example, 20 or 13 years old. Now we are using some companies that we make the processes of this. And I think
resampling is different. Resampling is different. You see, this is a resample. What it does, your sampling interval, for example, this is your sample interval, 0.01, okay? You can do that 0.01 to 0. Something else, like, let me show you. If you want to resample it into, say, 0.02, you can do that. It will take some time because your data is bigger, but you see, it is finished. So when I connect this, it will show me, say for example, it will show me the resampled. You see, sample rate is exponential 0.5. Input is different. You see, 0.0001. So what you are talking about is the resampling. You can able to do it, but for a binning or for a stack imaging, we require the data has to be in the CMP domain only, because your data is not in the CMP domain, it is a short domain data. For that, we need to have, as I said, the SPS, or you need to have the data like geometry from UCOVA P190. You see, either this is a marine data, so you should have a P190 file. So we can assign the navigation, then we do the geometry, and but I think for sub-bottom profile, it is not the case. It will be like this, like what you have shown me.
Yeah, but it seems to be very strange that it is impossible to convert times in depth. Because if you want to make, for example, analysis like frequency F cap analysis.
FK analysis?
Yeah.
You can do that. As I said, if you hear, as I said, bandpass, you can do FK filter. You see, I can apply an FK filter on this. Okay. But to convert time to depth, because you don't have the headers to make that happen. This is what I was trying to say. It's not saying that it is impossible or possible. If you have the right information in the trace headers, it can able to do it. So this is what I was trying to say. All the tools are available, but the important thing is what we require is, so here, for example, you want to remove something. Okay, say I think it is still processing. You see 0%.
Yeah.
At the bottom.
Yeah, but if you have the number of wave and the frequencies, you can derive from that the velocity. It's a mathematical application. Why you can do that?
I'm sorry?
If you have the frequency, the domain of frequencies, and the number of wave, so you can derive the velocity.
Probably I'm not familiar with that. So here, for example, if I want to remove those filters, right, in that zone, I mean, whatever the noise is there, by using the FK, it is still processing, you can see. So I can able to do that.
Okay, you have filtered the selection.
Yeah. Because your samples are pretty fine, so that's why it is taking a lot of time. Yeah, something is filtered, but we don't see that. Probably we need to generate the calculate difference. But yeah, as I said, everything you can able to do it, but we need the right headers to use the tools. I don't know whether I'm
There is
helpful to you.
in the modules like a calculator to write a function.
Sorry, can you please repeat it?
In the module here, when I want to apply a module to process data, there is like a calculator to write a function.
Expression calculator.
Yeah.
Yeah, it is there.
Expression calculator. Okay.
Yes. So you can do any mathematical expression if you want to.
Okay.
So here, for example, you say I'll simply explain you, okay, what exactly it means. So based on that, maybe you can understand. Say for example, this is gather A, okay. This is gather B from the same bandpass, okay. I want to find the difference between these two, right? So this is what we have removed from the by defining this, okay. But anyway, so this one we are talking about the expression calculator. I want to see the difference between A and B, okay, A minus B. So this will give me the output. Everything works, convert to depth conversion and everything does work, but we need the right trace headers. This is what important, because what I'm trying to say is, see, when I'm saying the trace headers, say this is I have that information on the trace headers, you see.
Yeah, about the source and the position of the source. Yeah. Okay.
Everything, and also you see the
yeah.
CDP is 0, okay. But whereas when I look into the stack imaging, so I have this information, all that information will be there. See, I have a trace number, and then I have a CDP number, I have an offset, I have an absolute offset. In your case, you have an FFID, okay, and then you have a offset is 0, you have absolute is offset 0, and there is no other information. So with that information, so I cannot able to.
Yeah, because the CDP is 0. Yeah, and the only solution is to write a mathematical expression to convert.
And also, and also we don't have the water depths also. Like I have the elevation, right? Here I have an elevation of 46 meters. But if you can have that, I can use the elevation to mute anything above 46 meters or below 46 meters. But you have an elevation of 0, right? See? You have an elevation of 0. So if they don't have any information, it is really tough. Maybe if you find something, that will be really great, but I have no other explanation or the solution for support and profile data.
Okay. Okay.